All right, so what's different about this problem? There's 3 terms. So what? You can do this with 3, 4, 5. Doesn't matter how many pieces you have, how many rational functions there are. I have to make the bottoms the same. That's the whole thing. So is there anything where you feel a reflex kicking in? That should be... Okay. Then, to make the bottom the same. Is this one missing anything, or is that the common denominator? Okay, Evan, you need to pay attention on this stuff, dude. So, that's missing something, isn't it? What's it need? The x plus 3 chunk. Because it has the x plus 5 chunk already, right? So this one needs an x plus 3, so I'm going to make it have one legally by using a clever one. All right, this one's missing
everything.
Both the plus 5 and the minus 5 quantities. So I think I need a little more space here, you know what I'm saying? So when you're working with these on your paper, try to anticipate and give yourself some space. So I'm just going to move this one out a little bit more. So plus, what was it? Plus 3 over x plus 3, right? Cool. So this one needs minus 5 and plus 5. And I could just write that both on top, or if I'm thinking ahead, I can be like, well, won't I end up foiling it anyway? Yeah. So I would write this on top and save myself some work. You don't have to, but, you know, I'm trying to show you efficient methods. I forgot something? You mean here?
Once you FOIL it out?
No, I didn't. Once you FOIL it out, difference of squares kills cross terms. That's why it's difference of squares. Minus 5x plus 5x go away. Usually, though, Lindsay has the instinct. She doesn't want to make that second fundamental mistake of algebra, which is forgetting the middle things, right? So nice. Good point. All right. This one's missing stuff as well, right?
Plus 5.
It's missing the plus 5 and the plus 3. Should we just like expand that right now? X squared, 5x and 3x is 8x. 5 times 3 is 15. If you want to take a whole nother step, fine. You're going to have a long problem if you do. So, all that stuff now has a common denominator at least of x minus 5 the quantity, x plus 5 the quantity, and x plus 3 the quantity. So then over here, if I expand this out, I'm going to get x squared plus 6x plus 9, I think. Yep. And then I'm going to be very careful right here because I have a minus. I'm going to go minus big parenthesis. And oh man, I really don't want to do this one, but I guess that's what we have to do sometimes. So I'm going to say I get 6 things out of this. So I get x cubed, 8x squared, 15x, minus x squared. I'm going to start erasing and changing. Now you guys are going to like that. Minus 8x, minus 15. I'll wait till you're a little older to do fancy stuff. Okay, so plus, this is all the common denominator, right? I should have centered it more, but that's okay. Plus, distribute here and you get 3x squared minus 75. Oh my goodness. All right. So, thinking about like terms. First I'm going to distribute that minus on top. I think we can safely erase there, can't we? So I'm going to say, let's get rid of these parentheses. The only reason I put them is so we didn't mess up. So that goes, makes this negative and this negative and positive, positive, positive. Okay. So remember, negatives, leave them outside, then distribute them. All right, so we've got negative x cubed. We've got some x squared terms. I'm going to color code since we got so many terms. So I'm going to say this one, this one, and this one. Jonah, are you working on this guy with me? Come on. Alright, so we got 2 minus 8 is negative 6, plus 3 is negative 3. Then I'm going to go and say, okay, x's. Let's see, I've got this one, this one, this one. 6 and 8 is 14, minus 15 is minus 1. And then constants, I have 15 minus 75 is negative 60, plus 9 is negative 51. Use a calculator if you want to, I think that's it. So then I've got x minus 5, x plus 5, x plus 3. You should always look at what your result is and see if anything factors. The top might factor. But what technique would we have to use back from chapter 6 if we were to attempt to factor it? If you run into anything like this in your assignment, which you won't on this first one, I would just leave it. But you could possibly factor this. It's probably not, difference of cubes is a good suggestion, Lindsay, but that'd be for like just like 2 terms. You'd have to be going to do this to attempt to factor this bad boy. What am I doing? So we need to whip out our calculator and look at synthetic division to try to factor it if that was indeed possible. So let's just leave it for today though. Okay, so there's one that was a little bit longer for you guys watching the video. Let's look at this one. So I'm going to get this all out of the way. Let's look at this complex fraction. What should I do first? Common denominator, that's different denominators. Where? On the very bottom, yeah? So to do a common denominator, my first step should be to see if this factors, which I think it does. What is it? 4 and negative 4 and 1? Okay. So negative 4 and positive 1. Alright, nice. That's almost that one, so that's not a big deal. Right? We just go fix this side up with a clever one. I'm not going to even touch the top yet. So that's going to be all equal to the top. Main fraction bar. When you have a complex fraction, you always want to make sure you focus on the main fraction bar. Okay? So I'm going to distribute here. That's 5x minus 20 minus x plus 4. So dangerous. Okay, so now I'm going to say this is all equal to the top. Let's just see if we can factor the top while we're at it. I think it factors. What can you do up there? They share 3. And then you'll have x squared minus 1. Oh, x squared minus 1. Also factors. That's difference of squares. Now I don't want to try to write this out like 3 more times, so I'm going to erase it and change it. Yeah. So that's x plus 1, x minus 1. Main fraction bar. And then we have some like term stuff to do here. So it's 4x minus 24. And then we've got this stuff on the very bottom. If I have one fraction divided by another fraction, I think we knew what to do. That is classic copy dot flip. Don't you multiply by the reciprocal? Those problems you guys saw before mainly had the division sign here. This means the same thing. So I'm just going to flip it up. times there we go. The main reason I'm telling you to focus on the main fraction bar is that's where the copy dot flip stuff is going to happen in the majority of cases, at least on the level of stuff I'm giving you guys at this point. Okay? So, can we cancel anything? Just a little bit, I think. We can go +1. And this guy actually factors more, doesn't it? Couldn't you go 4x minus 6? But that really doesn't cancel, so I think we're done. I think that's it. So this is going to cancel to all that's left on top is x minus 4. On bottom we have 3. We have x minus 1. 3 times 4 is really 12, and then we also have the x minus 6. There you go. There's another one. Let's see what else we've got. All right, so last 2 examples for this time. We've got another complex fraction here with fractions on the top and the bottom. At least there's only one on the top and bottom. That's pretty nice, because what could you do right away then? I don't need a common denominator. There's just one fraction over another.
Factor.
So I can factor first, that's a choice, or I can reciprocal it first because I've got one fraction over another. Kind of up to you. I think I'll reciprocal it first, okay? So let's reciprocal it first. And we'll get this. And as you're going, I mean, you can kind of start factoring stuff at the same time. I mean, if you don't want to write out a ton of work, which I know you guys don't want to, then kind of do what you feel comfortable with. I mean, that top one we're going to have to think about a bit to factor, right? So I'm going to leave it for now, but like this one, I hopefully we don't have to think about this one anymore, right? Jonah, what is this?
Could you factor it? Yeah, difference of squares, right?
Tell me the answer.
X minus 2x plus 2.
I'm glad you're with us. Okay, so then we're going to flip this one, right? So I'm going to go, so what's going to be on top? X plus 2. Oh, you can already see something that's going to cancel, right? And then on the bottom we're going to have 4x plus 16. Can we just factor that one right now? 4. Sweet. So the only thing on this problem that's going to give us pause or make us take a second is that trinomial where a is not 1. So this morning we voted. Let's vote. Everybody's got to vote. This is not like America where you can fail to vote. Everybody's got to vote. Are we going to do this with guess and check like I showed you guys yesterday, or do you want to do the algorithm? I don't care. Who wants? We want the algorithm?
Yeah.
Sounded like pretty unanimous. We don't even have to vote. No one wants to guess and check?
I want to guess and check, Mr. McGee.
I don't care. This morning they went with guess and check. But you guys are pretty confident there. So let's do the algorithm. All right. So over here, let's do it. I think this one would be pretty easy to guess and check, honestly, though, because you got 3x and x. That's the only choice, and everything's positive. And 4 could be 4 and 1 or 2 and 2, but it's going to be pretty easy to guess and check. Let's think about it when we're done. Okay, so algorithm, here we go. 12 and 1, clearly, right? I guess this is pretty easy too. 3x squared, I'm going to go 12x and 1x plus 4. What they share here is 3x. What's left is x and 4. What they share here is like nothing, so I'm just going to pull out a 1 and leave x and 4. And oh yeah, I did it right, because those big pieces share x plus 4, the quantity, so I can pull out the entire quantity and have 3x left here and 1 left here. So I can replace this guy with those factors. And I think quite a bit of stuff on this one cancels, doesn't it? So that's 3x plus 1 over 4 times the quantity x minus 2. Think about how easy this one would have been to guess and check. Now, I'm not really an advocate of that. I like the algorithm too, so I'm with you guys. But this one I probably would have guessed and checked because, I mean, 3x and x, okay? You could have put the 3x first and you'd be good. And then 4 and 1 or 2 and 2. If you guessed 2 and 2, then you'd have 2 times x is 2x, and 2 times 3 is 6x. That's 8x. Is that 8? No. So pretty quickly, I think you're going to realize I need more. So if I go with 4 and 1, and I put my 4 here so that I get 12, I can get one more from the other thing. I don't care though. But you ought to be able to be able to factor trinomials without a equals 1. This is not algebra 1 anymore. My kids could do it in algebra 1. I know some of you could do it in algebra 1. So you should be able to do it in algebra 2, I'm thinking, as well. So find a way that works for you. All right. Let's have a look at this one. This one's freaky a little bit. I don't know if I gave you any in your assignment like this. Maybe there's one at the end or something. Why am I saying it's freaky? It's good practice for your review worksheet I gave you this weekend as well. There's something freaky. What? Yes, that's what I was talking about. The power to the -1. What is that? That's, I think, what you should do immediately is go, anything with a power that's a negative, that means reciprocal. So write it as a reciprocal. And then you can just start common denominatoring stuff. Inside first. Right here. What's this need? Put these together. This needs an x down here. So deliver 1. Okay, so we've got 1 over x minus x over 1 plus x over x. Okay? Now you can flip something. Where? This could be flipped right now if you want as well. But since there's a bunch of stuff up here, I think it's better to go kind of keep on the inside. Think PEMDAS. Inside, resolve as much as you can first. And over here, if I zoom in, I can flip that guy right now. So let's flip it. So if I go 1 over x minus, and we got this x, times flip. Yeah. So now I'm going to put these together before I even touch the bottom. So I'm doing parentheses. There's parentheses right here if you think about it. Other ways to do this problem, but I think that's the safest way. So now I've got minus what? What is this?
X squared.
X squared over x plus 1. Does it matter if I write it backwards? Nah, we've been doing them like that mostly, right? So, now, to make those a common denominator, what's this missing?
1.
X was plus 1.
It's missing the entire quantity, x plus 1. That's its own unique individual piece. Make it legal. What's this missing? Because it's missing something too. Yeah, it has an x, but that's part of the x plus 1 piece. It's missing that x all solo. So up here, we've got x plus 1. The common denominator is x times the quantity x plus 1. Being very careful with my minus. And this is x cubed. And we still got the main fraction bar, so I'm going to write it big with 5 over x right here. I'm going to leave the original. Yeah, but it's not bad if you know a couple things. If you know about when to apply clever ones and stuff, this is not bad. Do I have any like terms or anything? These aren't like terms, right? They are what they are. I don't think so. So I'm going to write them in order.
X plus 1.
And I think I've got one fraction divided by another, so flip. Does Does anything cancel here?
Could you cancel the
X plus 1.
Are you looking right here?
Yeah.
It's a good question. Does this cancel?
Those are two
No,
separate
because-
things.
Why not? Think about visually why not.
Because
Well, because of
the
that.
shape.
Because of that. Yeah? But something cancels.
Is it the two X's?
Yes.
So one
Because this is multiplied, right? In between here is multiplied. In between here is multiplied. So this will cancel that, yes. And I think that's probably it. That's as good as we can do. So we're going to say it's this cubic thing on top and 5 lines on the bottom. Does that thing factor more? You'd have to consult synthetic division, but we're not doing that today. See you next time.